August 12, 2025, Cape Canaveral Space Force Station. A towering 198-foot Vulcan rocket gleaming under floodlights waits silently until 8:56 p.m. Two massive B-4 engines ignite with a flash. 4 solid rocket boosters erupt in unison, and nearly 3 million pounds of thrust rip through the Florida night. This isn't just another rocket launch. This is the first operational Space Force mission for Vulcan, a new era in America's military space power. Vulcan rises from Launch Complex 41, arcing eastward over the Atlantic. The solid boosters jettison just 90 seconds in, tumbling away into darkness. 3.5 minutes after liftoff, the first stage shuts down, separating from the 109-foot Centaur upper stage. From here, the Centaur's 2 hydrogen-fueled RL-10C engines take over, beginning a marathon burn to directly inject payloads into geosynchronous orbit 22,300 miles above Earth. At this point, the public broadcast goes silent. The rest of the mission is classified. Sources confirm 2 payloads were on board. One is fully classified. We may never know its exact purpose. The other, the Navigation Technology Satellite 3 or NTS-3. Built by L3 Harris Technologies, this experimental satellite will test advanced atomic clocks, phased array antennas, and jam-resistant navigation signals. Unlike traditional GPS satellites, which orbit at 12,500 miles, NTS-3 operates in geosynchronous orbit, remaining fixed over one spot on Earth.
With NTS-3, we're looking at how GPS can evolve, to remain the gold standard for our warfighters and for the world.
For decades, the Atlas V and Delta IV Heavy carried America's most sensitive payloads, but Atlas relied on the Russian-built RD-180 engine, a fact that became politically untenable. Congress demanded a US-built replacement. Enter Vulcan, 100% American with its B-4 engines designed by Blue Origin, Jeff Bezos' space company. The Delta IV Heavy is already retired. Atlas V has 13 flights left, all for civilian missions. After that, Vulcan takes over entirely. ULA's CEO Tory Bruno says Vulcan is built for exotic orbits, missions where accuracy is everything. Instead of needing 3 expendable boosters like a Falcon Heavy for direct GEO injection, Vulcan does it with 1 core. The key, its high-energy Centaur upper stage, able to carry more propellant to space and burn longer, placing satellites exactly where they need to be, saving them fuel, extending their operational life. SpaceX remains the dominant force in launch, 97 Falcon 9 missions already this year, but Vulcan isn't playing the low-cost, high-volume game. Its target is high-value national security missions, where reliability and precision matter more than price. For the Pentagon, a rocket that can deliver payloads straight to operational orbit without intermediate maneuvers is worth the investment. ULA plans 9 Vulcan launches in 2025, ramping to 2 per month by year's end, and as many as 25 in 2026. The company is upgrading its launch pads and production lines to meet this tempo. This first Space Force mission proves Vulcan is ready. Now it's about delivering over and over again. The Vulcan's first Space Force mission wasn't just about putting satellites in the sky. It was about ending the Atlas era, retiring foreign engines and solidifying America's next-gen heavy-lift capability. With missions like NTS-3, we're not just maintaining GPS, we're future-proofing it. But here's the question. In a market dominated by SpaceX, can Vulcan carve out its own future, or is it destined to remain a niche player for government payloads? Drop your thoughts in the comments, like, subscribe, and ring that bell. Because in spaceflight, the next big launch is always around the corner.